Good morning, CP Pre-Calc. And what we are doing today is we're going to continue working with hyperbolas. So let's look at example 5. Now you had to go up to example 4 for homework last night, and below is the key to that homework. So just make sure you check it later to make sure that you understand what we had to do. Now, the only difference is when we look at number 5, I'm just going to extend something. We're going to talk a little more about the asymptotes today, and then we're also going to talk about how to rewrite the hyperbola in standard form. But we're going to start with what we did yesterday and said, okay, I want to look at this standard form of the hyperbola, identify the center A, B, the vertices, the foci, and where my asymptotes are, and how I draw my box. Now, the first thing we want to always do is identify if it's an up or down or a side to side. And whatever variable comes first. When you have a hyperbola, you have that subtraction sign there. So whatever variable comes first identifies if it's an up to down or side to side. Now this here, since y is first, we know this is an up and down parabola. I'm sorry, hyperbola. Up and down hyperbola. You make it a little thicker. It's easy to write. So we have an up and down hyperbola. Okay. Now that helps us identify what we have to add and subtract everything from. So you're really working with, when you're thinking of an up and down, you think of y. We're working with our y variable. So now if I take a look at this, I also in the hyperbola, a is always under the first variable, b is always under the second. So you have a squared is equivalent to 9. Therefore, a is 3. And you have b squared is equivalent to 4. 16. So B is 4. If I think of my center is HK. H is always subtracted from X. What is subtracted from X here? Since I have an X plus 1, that means negative 1 is subtracted from X. I have a Y minus 1. Positive 1 is being subtracted from Y. That is my center, my HK. Now, how do we identify our vertices? In our vertices, we add A to one of our values. How do we determine what I add A to? Well, if it's an up and down hyperbola, I am going to add A to my Y value. So you're going to add A to the Y value, and you're going to subtract A from the Y value to find your two vertices. So you have negative 1. 1 plus 3 is 4. Negative 1. 1 minus 3 is negative 2. So that up and down helps us identify whether we add or subtract from the X or the Y. Now our foci too. A foci we're going to add and subtract from the same value I subtracted my vertices from. Up and down, foci, you're going to add and subtract from your Y value, which is the Y value of your vertex or your center in this case, your Y value of your center, which would be K. So remember, C squared is equivalent to A squared plus B squared. Well, A is 9, A squared is 9, B squared is 16. So C squared is equivalent to 25. Therefore, our C would be 5. That value is what I'm going to add to the Y value of my center. So I'm going to have negative 1. 1 plus 5 is 6. Negative 1. 1 minus 5 is negative 4. And remember, I am subtracting from here the Y value of my center. And the reason I'm using the Y value is because it's an up and down hyperbola. Good job, guys. So now what I'm going to do is we're going to think about the graph and the box. All right. Now, again, the first thing I like to do is my center. I have negative 1, 1. That is my center. So right here, I'm going to put a negative 1, 1. That's my center. I'm going to count from there. Now, if we think of our box, I told you the box helps us identify the asymptotes. Now, if I think of my box, I'm going to count. We can do our vertices first. Hold on. So here's my center. I'm going to just, hold on. I wanted my center. My center's in green. My center's green. I'm going to then put my vertices in purple. My vertices are in purple. So if I do my vertices in purple, I'm going to have, actually I should make more lines. Okay, so we have this. If I do those vertices in purple and I look at this, I have -1, 4. And then I have -1, -2. There's my vertices. Now to make the box, the vertices help us identify the top and the bottom of the box in an up and down hyperbola, but I'm also going to use my B value. So that A value kind of goes to this up and down because it's up and down parabola, but that B value is going to go left and right in the up and down parabola. So if I go left and right, that means I go from my center and I count 4 to the right, 1, 2. So if I count 4 to the right, think about it. You start at your vertex and you go 1, 2, 3, 4. I started at my center and I went 4 to the right, start at my center and go 4 to the left, 1, 2, 3, 4. So you went 4 to the, if I mark it down, I went 4 to the right and 4 to the left to help me make that box. So now I can make this box. So I make a box with vertical lines and horizontal to make that box. And I went a little far. Sorry about that, guys. Let's erase that. Now that box helps me identify my asymptotes. Now your asymptote will go through the center and the opposite corners of your box. So if I draw my asymptote, it's going to go through the center and opposite corners of the box. We have 2 asymptotes. We're going to call them slant asymptotes of our hyperbola. They're slanted because they are not vertical or horizontal. All right. Now it's an up and down. So I know if I graph this, if it's an up and down, it's going to go from the vertex up and the vertex down. Now, if I want to graph my last thing, my foci here, let's pick a new color. Let's do a brighter blue. If I want to graph that foci. All right. I'm going to say here, I need to make sure it's a thicker point. I'm going to graph -1, 6. Right? So this is 4, so -1, 5. I will be up here, -1, 6, and then -1, -4. 1, 2, 3, 4, and that would be my 2 foci points. So this would be foci 1, and this would be foci 2. Now, the only thing we're going to add today is we're going to actually write the equations of the asymptotes. And how do we do that? Well, in order to write the equations of the asymptotes, I want you guys to recall a formula. So let's recall one formula before we write the equations of the asymptote. I want us to recall, let's say, point slope form. Okay, guys, so let's look at point slope form. Point slope form, if we have a point and a slope, our equation of our line is y minus y1 equals m times x minus x1. M is our slope, and x1 and y1 are a point on our line. Now, we're going to write the equations of the asymptotes. So if I'm going to write my equations of my asymptotes, I'm going to have 2 equations because I have 2 asymptotes. And I'm going to highlight them right now. If I have my 2 asymptotes, I have 1, 2. Those are my 2 asymptotes. Now, the point that we know is definitely on our asymptotes will always be our center. So this center here, we know our center is right there. That center is always on our asymptotes. So that center point is -1, 1. That will always be on my asymptote. That is the point I'm going to use in point slope form. So now let's think about this. I can also easily find my slope. Your slope is going to be found rise over run. So let's think about this. Let's do rise over run. I start at my center and I go to that corner. Think about what I did. I went up A. This is up 3 over 4. So the slope of this line, one of the asymptotes, would be 3/4. The difference of my other asymptote is if I take another thing, I'd go up 3 to the left 4. That means if I look at that one, the slope of my second asymptote would just be -3 over 4. So your equations are going to be very similar. The only thing that's going to differ in the 2 equations is one will have a positive slope and the other a negative. So in this case, we're going to use that center When I use that center, negative 1, 1, that's going to be the x1, y1. Okay, that's my center. And then we're going to use our two slopes that we have. So my first slope is a positive 3/4. So I'm going to write y minus 1, because 1 is the x value of my center, equals 3/4 x minus a negative 1, which is a plus 1. That is one asymptote. The only thing that will differ with the second asymptote is it will be a negative 3/4. So the two equations will look very similar, but these here will be the two equations of the asymptotes of my hyperbola. All right. Okay, guys, let's go to another one. Let's take a look down here, number 6. Now we're going to do what we just did, but we're going to add a step. We are going to have to first rewrite the equation in standard form. And we've done this before, guys. We just haven't done it with the hyperbola yet, but we've done it with the ellipse and the circle, and we're going to use the same method. We're going to be using a method of completing the square. Now, the only thing different here that I want us to make a note about is that if we are going to complete the square, the key thing that we want to make sure we know, you want to put the squared variable, actually, let me put a word in front of that, the positive squared value first. Positive squared value first. That's what I want to do. Put the positive squared value first. So if I take a look at this, I have negative 9x squared and a positive 16y squared. I'm going to put that 16y squared first. And when I complete the square, I usually always put my y terms first, then my x term, and we put, remember, the constant on the other side so that negative 128 becomes a positive 128. Okay? Now, to complete the square here, the x, I don't have to complete the square because there's no x term. I only have an x squared term. I have to complete the square of my y, though. So when I want to complete the square of this y, I need to first factor that 16 out. So I'm going to factor that 16 out, and I have y squared, negative 32. If I factor positive 16, I get a negative 2y. I have a negative 9x squared equals 128. All right, I'm going to actually condense this so I have a little more room, guys. Now, if I complete the square here, remember, you take your b value, which is negative 2, divide it by 2. So you take negative 2, divide it by 2, and square it, which is a positive 1. So I'm actually going to add 1 to the left in the parentheses. But remember, whatever I add inside the parentheses, before I add it to the other side, I must multiply it by the number on the outside. So I'm adding 1 inside the parentheses, but I'm really going to eventually multiply that 1 by 16. So I have to add 16 to the other side. And now we factor. You have 16. If I factor my next term, I get y minus 1 quantity squared, because that is a perfect square trinomial, minus 9x squared is equivalent to, so when we take a look at this, this is equivalent to 144. Now, we want to continue putting this hyperbola in standard form. So I want to divide both sides by 144. Because in the hyperbola in standard form, we have a 1 on the right side. So if I simplify this, I'm getting y minus 1 squared over 9 minus x squared over 16, because 16 goes into 144 9 times, and 9 goes into 144 16 times, is equivalent to 1. This is my standard form right here. So now I know by looking at that standard form, I have a lot of information. I know it's an up and down. So if I look at this, we have an up and down parabola because y is first. Hyperbola, I keep on saying parabola, hyperbola. I have an up and down hyperbola. So let's go through the motion. So I want to graph this. So let's identify the center. What is my center? My center, if I want my center, actually, let me make some tick marks first. I don't know why. If I want to identify that center, you look at our center and we say our center is, what's subtracted from x? 0. What's subtracted from y? 1. So 0, 1 is my center. Okay. Let's think of what A is. Okay. A is going to be, if I think of A is going to be under the first term, B is under the second. So I know A squared is 9. A squared is 9. So A is 3. B squared is 16. So A is 4. Now that's what I count. So if it's an up and down, this tells me if I'm going up and down, that means A is what I'm counting up and down from my center. So if I'm counting up and down from my center, which is A, I count 3. 1, 2, 3. I count down. 1, 2, 3. Okay, B is what I'm going to count down. I don't know why I wrote an A there. B is what I'm going to count down from. All right, B is what I'm going to count down. I'm sorry, across from my center. So I'm going to go left and right. So go to my center and I count 4 to the right. 1, 2, 3, 4. 4 to the left. 1, 2, 3, 4. Now I can make my box. Okay. You make a box with your A and B values. They help us identify our asymptote. So let's identify our asymptotes. So now we have this. We are going to draw our asymptotes. Draw one here and one here. We know it's an up and down hyperbola. So I know I can actually draw my hyperbola touching that vertex, which is where we have here. Now, if I want the coordinates of my vertex, think about it. How do we do that coordinates of my vertex? Remember, we add A to what value? Well, the up and down helps us determine it. If I look at my vertices, okay, I'm adding A. You guys are actually going to do number 7, but I'm just going to write below, just have room right now. So if I look at the vertices, if I add A to Y, I'm adding A to Y of my center because it's an up and down parabola. So my vertices will be 0, 4, because A is 3, and 0, -2. Those are my vertices. Now I have to figure out my foci. If I look at my foci, first I need to do C squared equals A squared 9 plus 16. So C is actually going to again be 5. And I'm adding that to Y. Why am I adding that to Y? Because it is an up and down hyperbola. So I have 0. If I look at my center, 1 plus 5 is 6. And then I have 0. 1 minus 5 is -4. So now I can put those two values as my foci. 0, 6, which is up here. 0, -4, which is down here. So I would have foci 1 and foci 2. Oh. Okay. All right. That's what we would have. Okay, so that's how we find out 6. Okay, so we're just adding that, completing the square fact concept in that we've done with circles and we've done with ellipses. So we're just adding that step. Now the other step I'm just going to add in is we want to find the equations of the asymptotes. How do I do that? The equations of my asymptotes. So just ignore 7 right now. Just pretend it's not there. We'll do that. You're going to do that later tonight. Just, all right. So if I take a look at that, if I want my equations of my asymptotes, what I'm going to do is take a look. The center is important. I need to know my center. That is my x1, y1. I need my slopes. Now let's look at our slopes. Count. I'm going to highlight it. I go up. I went up 3 over 4. 3, 4. So the slope of this one here would be, this asymptote is 3 over 4. The only difference from my other asymptote, I'm going left 4. So your slope of your other asymptotes would be negative 3 over 4. So when I write that, you have the center. Y minus the y value of center, which is 1, is equivalent to 3/4. X minus the x value of my center, which is 0. So it's just x. The second asymptote would be y minus 1 equals the opposite slope of negative 3/4 x. That's the only way they differ. And those are the equations of my two asymptotes. All right, guys? Your assignment is below. If you have any questions, please come to my office hours on Google Meet. I will send out an announcement. All right, you have a couple of problems for homework tonight, and I hope to see you guys at office hours or email me if you have any difficulties or questions. Have a great day, guys. Bye.